Hello dear grade 10s. Today I'm discussing the quantitative aspects of chemical change. Now this section is really important from now up until the end of matric, and if you continue at university you will always use it. Now this concept of the mole is what I'm focusing on. And it says here, the mole is the SI unit for the amount of substance. So SI means Systems International. It means all over the world, they use the concept of the mole in chemistry. And we have to come up with this idea because in chemistry, we work with small quantities and grams won't do. So we come up with this concept of the mole. It's a unit, and I'm going to use it as a word as well, so that you don't get confused. Now let's look at the definition. It says the amount of substance having the same number of particles as there are atoms in 12 grams carbon 12. So why carbon 12? Well, there's carbon 13 and carbon 14. Carbon 12 has 6 protons and 6 neutrons, and that's the one they used to compare for everything else. So let's pretend I have carbon 12 in the lab, and I've got exactly 12 grams of it. If it were physically possible, I could count how many atoms I have. And I will come up with a number. You'll see it later. It's 6,02 times 10 to the 23 atoms. Now, it's ridiculous to assume that I can count that number, but let's just play the game. If I have 6,02 times 10 to the 23 atoms, I am saying I've got 1 mole of atoms. So look at the definition again. The amount of substance having the same number of particles. It doesn't say atoms, it says particles. So what are particles? Well, let's look at this slide. These particles refer to atoms or molecules, formula units, or ions. Let's look at atoms. Firstly, atoms are from your periodic table. So they could be magnesium, copper, zinc, iron, chlorine, neon. It doesn't matter. As long as it's on the periodic table, I'm talking about atoms. I could have particles that are molecules. Now, molecules could be oxygen gas, that's O2, nitrogen dioxide, NO2, any combination of atoms that are forming a molecule. That means covalent bonding. So you know we did the section on particles making up substances. And for this year, in COVID year, they took the section out. But I'm glad I did it with you, because then you'll know what type of molecules we're talking about. Water is a molecule as well. Then the other type of particles we're talking about is formula units. Now here we're talking about ionic substances. So they're not molecules. I can't call them molecules. I'm going to call them formula units, because Na plus and Cl minus make up 1 formula unit. If I put this in water, it will split up into ions. So I'll have an Na plus ion, I'll have a Cl minus ion. Any substance that is a formula unit, anything that is ionic, if I put it in water, it will break up into ions. So I have 4 possible types of particles. And if I have, let's go back to the slide. If I have the same number of these particles, any of these particles here, if I have the same number as there are atoms in 12 grams of carbon 12, then I have 1 mole of particles, whatever particles I'm focusing on. Back to slide 1. Excuse me. The symbol for the mole is a small letter n. Now you can't write a capital N because that has a different meaning. So you have to go with the small letter n. So let's go again. Concept of the mole, it's the unit for the amount of substance. The definition, learn this off Don't try and change the words around because you might lose the meaning. Learn it off. They will ask that in the exam. Here's your symbol, small letter N. Now let's look at slide 2. I explained to you what particles involved. I gave you an example of what type of particle I'm talking about. Now there are some concepts that come up in this section, like relative atomic mass. We've done this before, but I'm going to repeat. So it's the mass of a particle on a scale where an atom of carbon-12 has a mass of 12. So I'm saying carbon-12 has 12 particles, its mass is 12. And there's no unit. Whenever I use the word relative, we don't have a unit. So if I go to the periodic table and I look for magnesium, and I'll see it's got a mass of 24. So that's its relative atomic mass. Copper, I think, is 63,5. N for nitrogen is 14. So if you look at your periodic table, you'll know what I'm talking about. Here it's just oxygen. Leave out the 2, just oxygen. That's 16. Just sodium, 23. Just chlorine, 35,5. That's relative atomic mass. I didn't mention a unit at all. Now related to that is molar mass. Look at the word molar coming from mole. So it's the mass of 1 mole of a substance measured in gram per mole. This is important. I did not use the word relative, so I have to have a unit. Gram per mole. That means how many grams in 1 mole. That's the mass of 1 mole. Then I've got relative molecular mass. So relative meaning no unit. Here I'm talking about a molecule. So compared with atomic, slightly different. Like water has a relative molecular mass of 18. If I talk about relative formula mass, word relative, no unit. Formula mass, like this one here, is 58,5. So that's what I said about the units. Now moving to slide 3. I hope you're coping. This idea of Avogadro number, very, very useful. It's a person's name, and Na is Avogadro number. What does it mean? It says in 1 mole, you will have 6,02 times 10 to the 23 particles per mole. Per mole means in 1 mole. This is a very large number. So instead of using this number, we say Avogadro number. And it says the number of particles. Again, my particles are atoms, molecules, formula units, or ions that are found in 1 mole. So 1 mole will always have this number of particles, always. Let's look at an example. Again, carbon-12 comes up. Take 12 grams of carbon-12. Why did I choose this number? This is from the periodic table. It's relative atomic mass in grams now. So 12 grams of carbon-12 has Avogadro number of atoms. Now again, it's tiring to say Avogadro number, so I just say it has 1 mole of atoms. If I look at the next example, 18 grams of water. You see, water has a relative molecular mass of 18. So if I take 18 grams of water, let's say I had it in a cup, and let's say I could physically count how many water molecules there, I would come up with Avogadro number. Not possible, but that's the theory. And what is it? It's the same as saying 1 mole of molecules. Here, I'm talking about a formula unit. So if I take 58,5 grams, how did I get this? It's 23 plus 35,5. 58,5 grams. Then I have Avogadro number of formula units, or I just say 1 mole of formula units. Now in this section, you're going to use the mole in the following ideas. You're going to calculate volume of gas, or number of particles, or mass of substance, or the concentration if you have a solution. So I'm calling this the traffic circle because everything has to go past the traffic circle to get somewhere else. Let's assume the examiner says, he gives you a mass of a substance and he asks you how many particles in that substance. So let's say he gave me 24 grams of carbon and he wants to know how many atoms there. This is mass in grams. I will use this formula here, which is number of mole is equal to mass in grams over molar mass. I'll find the number of mole, that means go there, and go around the circle and find the number of particles using this formula. Number of mole, which I got from mass to mole to particles, Na is Avogadro number, and this is what I'm finding. N is the number of particles. This equation and this equation are both in your data sheet, so you don't have to learn them off. You've got to know how to use them. If I give you mass, let's say I give you a gas like carbon dioxide, and I say, what volume does it occupy at STP? What does that mean? I'm here at mass. I need to get to volume. So I've got to go from mass to change it to mole to change it to volume. How do I do that? I use this formula here to find number of mole. That means I go here. And then I use this answer in this equation here to find volume. This letter Vm is molar volume. And that value is given to you in the data sheet as well. We'll work through it later. If I have a mass again, let's assume I have 58.5 grams sodium chloride and I mix it in water. And I want to know what's its concentration. So I'll find number of mole first using this equation. That means I'll find number of mole here. And then I'll go ahead and find the concentration using either this equation or this one. This says concentration is mass over molar mass times volume, or concentration equals number of mole over volume. Now I'm going to send quite a few examples for you to do in the next lesson. That's all for now. Thank you.